I'm Natasha Curry.
I'm Jorge Flores.
And I'm Jacquie Vargas.
And this is our high dive recording.
In this unit problem, we are given the scenario of a circus act in which someone dives off a high platform from a Ferris wheel into a small tub of water. Some information given to us is that the platform sticks out perpendicular to the plane. The platform stays parallel to the ground. The car starts at 240 feet from the left of the Ferris wheel center. This car contains a water level of 8 feet inside the tub.
A really important fact to notice with the Ferris wheel is that the wheel turns in a counterclockwise motion. Every complete turn is 40 seconds. This makes the angular speed 9 degrees per second as well as 7.85 feet per second. Following, the radius of the Ferris wheel is 50 feet and the center height is 65 feet.
The diver is held by the ankles by an assistant. The assistant must let go at the right moment so that the diver could land in the moving tub of water. Our task in this problem is to determine the exact time that the assistant will drop the diver in the cart.
To get started with tackling this unit problem, we first assume the Ferris wheel to be like a clock and determine the height of the diver at each hour mark, which represented every 10 seconds in terms of the Ferris wheel. We also made other assumptions related to the movement of the Ferris wheel. We have to keep in mind that there wouldn't be any wind speed that would disturb the motion of the Ferris wheel or other gravitational factors that would affect the movement of the Ferris wheel.
Through the derivation of the formula, we came up with h of t equals 50 sine of 9t plus 65 to represent the height h of t after t seconds. The input here would be the time and the output would be the height. 50 represents the radius and 65 represents the feet off the ground from the center, while 9 degrees represents the angular speed of the Ferris wheel.
If we plug in 10 seconds for t, we should get 115 for the height. Following, in terms of physics, the original formula to figure out an object's falling speed is t square root of h over 16. In order to find the diver's falling speed in seconds, we just substitute the whole equation with the change 57 to it, since we have to keep the water level height of 8 feet in mind. And we put that over 16 since it has to do with gravity, and we can get the diver's falling speed. Following, the whole point of the unit problem was to figure out the exact time that the assistant lets the diver go. But we have to keep in mind that the cart is moving. If the cart begins moving when the Ferris wheel passes the 3 o'clock position, the formula that we came up with to represent how much time the cart would travel for was w plus h over 16. This shows that the wheel time is added to the falling speed of the diver.
We learned that sine has to do with the y-axis while cosine has to do with the x-axis. In the unit problem, we were asked to find the exact location for where the assistant would drop the diver. So that means we need to find the horizontal distance that the car would have to be in.
This formula shows the horizontal distance or the x-coordinate that the cart travels in w amount of seconds. The x-coordinate is the location, 50 is the radius, 50 cosine of 9w is finding the unknown length for w seconds.
If we plug in 20 seconds for w, the x-coordinate should be negative 50 since that is how it appears on the Ferris wheel.
Now that we know which formulas are with and what their inputs and outputs each represent, we can solve the unit problem.
To solve the time at which we should drop the diver, we had to keep in mind that the cart's position has to equal the diver's height because we want the diver falling inside of the cart, not somewhere else. The way we do this is simple. We set the cart's position equal to the diver's height position equation, as you can see here. Our group decided to first guess and check before we graph, but after guessing and checking, the closest that we got to the time was 12.28 seconds. After graphing, we saw that the exact time when the diver should be dropped, which was the intersection, was 12.283 seconds.
Next, using the equation square root of h over 16, we conclude that the diver will be falling for about 2.55 seconds after being dropped by the assistant.
The total time for the cart to travel is represented by the formula w plus square root of height over 16, but the height is 57 since it takes into account the water level of the cart, which is 8 feet off the ground. After simplifying the problem further, we got that the cart has to travel for about 14.8303 seconds until the diver dives into the water.
Now that we know that the diver will have to be released at 12.283 seconds after a 3 o'clock position, we can determine that the height at which the diver is released by just plugging in 12.283 into the height formula. This is the height formula, and when we substitute 12.283 seconds for t, we end up with the height of about 111.8192 feet when the diver is released.
To find the location where the diver should land, we just plug in the 12.283 seconds to the x-coordinate formula to determine the x-coordinate location of where the diver is at 12.283 seconds. And assuming that the diver would land straight down, after plugging that in, we found that the x-coordinate that determines the horizontal location of where the diver should land is approximately negative 17.549 feet.
Finally, we can say that the final location of the cart has to be represented by this formula. This formula takes the speed of the cart, 15 feet per second, and multiplies it by the amount of seconds that the cart will travel for, and then subtracts everything from starting position.
This sums up our answer to the unit problem, the circus act.